Alright, second half, stationary points. So you found out, how to find the tangent equation, normal equation. Now you're going to go to stationary points. Okay, now if you remember from last year, stationary points is just basically when the gradient is 0. Okay, so stationary points occur where the gradient is equal to 0, which means that your tangent line has a gradient of 0. The only way to have a gradient of 0 is if it's a horizontal line. So going back to year 9, you've got your positive line, negative line, 0 line, and undefined line. So all they're really saying is, as long as you can draw a horizontal line on the curve, you've got a stationary point. At that particular point, that tangent line that has a 0 gradient is a stationary point. So this is the line I want you to use if you're in the exam in some way. I don't care how you do it, but you have to state stationary points occur when the derivative is 0. You have to show that you understand. That's the 1 point. That's 1 skill point. It's normally 2 marks. That's your 1 mark. 1 mark is to show the derivative of the curve gives you the stationary point if it's equal to 0. Okay? What you shouldn't do is just jump right into the equation without writing anything and write 0 equals 2 and then 2x squared plus 3 or something like that. Okay? That is not good. Because the examiners will look at it and it's like, well, why'd you put 0? A lot of things we do in mathematics is let things equal 0. For example, null factor law, let it equal to 0. When we want to teach you transformations, let it equal to 0. See, it doesn't mean that you understand it, but you writing down stationary point occurs when the derivative equals 0, and then you take this step, it's okay. Okay? So make sure when you're doing the questions, anything with stationary points, maximum minimums, write that line in. Okay? Derivative equals 0 for stationary points to occur. Now, say these curves, these points are the only points where you can get a horizontal tangent line. Because every other point now is going to be a positive tangent, a negative tangent, but eventually you will have another one which is 0. So negative, 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 0, positive, 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 positive. Okay, so that's why they happen to tell you the maximum and minimums. So we know at the maximum or minimum, the derivative of the derivative of the curve at that point has to be 0. Okay? Now, having said that, so this is what we know. Gradient 0, derivative curve is 0, therefore you've got a stationary point. The different types of stationary points, okay, because all I told you was it can either be a maximum or a minimum. It's when you're gradient 0. But it doesn't mean that it's maximum or minimum. It could be an inflection point as well. So the types of stationary points you could have this point. That's what we call local maximum. Make sure to copy this down. Local maximum, local minimum. And then you have a point of inflection, which is just basically saying it's a positive gradient and it gets very low positive and it gets to 0. And then it continues growing again, so it's positive, 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 positive. How's it different to local maximum? This is positive gradient, positive gradient, positive gradient, then it becomes 0. After the 0, it becomes negative, 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 negative. That's a local maximum. So I'm talking about gradients right now. Negative gradient, negative gradient. Whereas over here, negative gradient, negative gradient, negative gradient, then you have 0, and it becomes positive, positive, positive. So you can see the difference between them. Local max, positive, 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 0, negative, negative. Local minimum, negative, negative, 0, positive, positive. Inflection point. Positive, 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 0, positive, 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 positive. Or you could have negative, 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 0, and then negative, negative, negative. Okay, so that's why when you say the gradient's equal to 0, there's 3 different types. And in your exam, it's likely they're going to ask you to prove, and they always say justify, show that. All those questions, you can't just say local maximum, local minimum. It's not good enough. You have to show it. And that's what this exercise is about, 10C, and anything onwards is to get you to get in the mode where you prove whether it's a local maximum, local minimum, or stationary point. If you're wondering how to prove, you just need to show gradient at that point is 0, gradient anything before that is positive, gradient anything after is negative. You've shown that it's a positive gradient. Okay, sorry, it's a local maximum. Okay, that's how you show it. But anyways, here we go. So this is just me quickly showing you the different types of gradients we're analyzing. Okay, so let's go through it again. What did we just learn in the second half? Stationary points. When do stationary points occur, Gary? When do stationary points occur? How do you know when you have a stationary point? Yeah, when the gradient's 0. How do you find the gradient of a curve? If you want to know if the gradient's 0 or not, what do you do, Pius? If you want to know if the gradient's 0, what do you do? You've got a curve, let's say y equals x squared. How do you find the gradient, is all I'm asking. dy dx. So you just said stationary points occur when the gradient's 0. To find the gradient, you told me, find dy dx. Find dy dx at that particular point. If it's equal to 0, it's a stationary point. How many different types of stationary points do I have, Murray? Three. There are only 3 types. Local maximum, local minimum, stationary point of inflection. Okay, now your stationary point of inflection could be negative 0, negative, or it could be positive 0, positive. Okay, so I've just summarized what you need to understand, and that's 2 exercises. That's 10C, 10D, and then I can show you 10E very quickly, which is the next 2 points. Here we go, 10E. Okay, so I've pretty much put you in 10A, 10C, 10D, 10E, all in today's session. All you're really doing was what? Tangent, normal, gradient, stationary point. They're all very straightforward. You don't have to study hard. Learn it, understand it. Don't do laborious work, because that doesn't get you to understand it. Try to picture what's going on. So here we go. What's in exercise 10E? Exercise 10E, absolute maximum and absolute minimum. What's absolute maximum, absolute minimum? They're just descriptions of the lowest y value. This is your absolute minimum. This is your absolute maximum. Whoops. Okay, so absolute maximum, absolute minimum is just basically what is your largest y value, what's your lowest y value. If you actually know what your absolute maximum minimum is, you know what your range is. Okay, that's all it really is. So absolute max, absolute minimum. That's different to local maximum, local minimum. Because I can have a graph that looks like this. I can have something like this. Okay, so that has multiple maximum, local minimum, local maximum, local minimum, local maximum, local minimum. That's my absolute minimum, absolute maximum. That's the difference between them all. Okay? And you're just doing the same drill over and over, 10D, 10E, and 10C. It's the one topic. See, I've summarized it all in just one theoretical point. It's one concept. Stationary points occur when derivative equals 0, or the gradient equals 0. Okay? Let's do an example. 10C. I want you to find the stationary points. Remember, stationary points, and this happens in your Year 12 SACs very often, points. Points has an x and a y coordinate. I didn't ask you just to find the x coordinate, find the x and y coordinate. It happens all the time. I get students giving me the SAC and they've got, yep, found x. It's a point. Point has an x and a y coordinate. So find out your y values as well. Okay? So remember, to find out the stationary points, when do they occur again? When the derivative equals 0. Good. So when the gradient is 0. How do you find the gradient? Pi said, find dy dx. So the first job is to find out dy dx. You know that if dy dx equals 0, whatever x is to make that equal to 0 is where the x coordinate is. So find dy dx first. found dy dx. Remember, don't just jump into the equation, don't do this in the exam, don't just write 0 equals 2e 2x minus 2, don't do that. Okay? Write y. Why did you put that 0? Because when dy dx equals 0, there's a stationary point. If you didn't want to write that, you can say stationary point at dy dx equals 0. This is okay too. But you just need to say that you know stationary points will occur when you know that the gradient is 0. Gradient is 0. dy dx is the gradient. Okay? So all you're really doing there is now you know, okay, if this is 0, 2e 2x minus 2. Your job is to solve for x. Sometimes in this step here, I find students write this, and then they sub x equals 0. I don't know why. You just told me dy dx equals 0. That is your dy dx, right here. That's where 0 is, not here. Okay, so understand what you're doing. Don't do it blindly. Understand what you're solving for. In our case, we're finding x. X is the x-coordinate of your stationary point. It's the point where you're going to get a 0 gradient. Okay, so solve for that. Add 2 on both sides. You've got 2 equals 2e to the power of 2x. Divide both sides by 2. So you get 1 equals e to the power of 2x. Anyone remember how to solve this now? How do you remove the exponential function? What do you do? Anyone remember? What's the inverse operation of exponential? Log. Okay, so if it was 2 to the power of 2x, then you do log base 2. But this is exponential, so you'd say log both sides. I'm going to do it in red so you can see it. All I'm doing is balancing the equation. Log e on both sides. Whoops. Okay, log e on both sides, they're inverses of one another. So you're removing that function, and you're left with now log e of 1 equals to 2x. We'll get to logs eventually, and I'll revise that with you, but that's after your SAT. So here we go. Log e of 1, anyone know what that means? Or what it equals to? 0. Because what it's really saying is e to the power of what equals 1. And we all know e to the power of 0 is 1. So I know e to the power of 0 is 1. So therefore, this has to equal to 0. Therefore, x is equal to 0. And this is what I'm saying. Most students stop here and say, there you go, found your stationary point. No, you haven't answered the question. The question said stationary point. You found the x coordinate, find your y. How do you find your y coordinate? What do you do? Sub it back in, not into the derivative, into this. Because this tells you the y coordinate, not your gradient. You don't want your gradient. Okay, so sub x equals 0 into y equals e to the power of 2x minus 2x. So you get y equals e to the power of 0 minus 0. Y equals 1. You're not done yet. Why? Why am I not done yet? If you did this in the exam, I wouldn't give you a mark or a sack. Yeah, you haven't answered the question yet. The question said, what is the stationary point? Find the stationary point. You just went x equals 0 and y equals 1. I have no idea what that means. Answer the question. Be specific. In our case here, we'd then say, therefore, stationary point at 0, 1. See, that's a proper answer. That's what they're looking for. So 1 mark here, 1 mark here. Okay, it's never going to be a 3-mark question. It'll be too easy for you. Unless they're feeling generous that year and they thought, give you some free marks, then it'll be a 3-mark question. Otherwise, this is 2. Find the derivative, write out your answer. Write it properly. Okay, don't skip. If you skip, you lose a mark. But if you don't skip, you get a mark. Potentially get a mark anyway. Okay? Have a go with the next one. Next one is a product rule. In case you forgot your product rule, dy dx is vu dash, oh my god, what's going on with it? VU dash plus UV dash. Using product rule. Have a go with that, and then we'll call that it for today's session. Put it all together. Tangents, normals, stationary points, types of stationary points, maximum, minimum. Find out the derivative. The hardest thing is to find the derivative. Untitled Chapter 9.
What's the derivative? One-third. No. It's one. Yeah, it's one.
Either the 3x equals negative 1.
That was the first time.
Can you do that by hand?
Laborers coming
Alright, hands up if you got up to this step. So you found the derivative using product rule. Let x equal to u, let v equal to log u of 3x, find the derivative of each. So revising your log and exponential rules, the derivative should have been 1 and 1 on x, using chain rule here. Using product rule is what you get. Let equal to 0 to find stationary points, minus 1 on both sides. Now, the reason why I'm asking if you got up to this step is because now this is exponential and logs. Remember, they're inverses of one another. What's the opposite of log? Exponential. So it's log base e, so therefore you do the exponential on both sides. So as we go. I'm going to do the exponential on both sides. E to the power of negative 1, e to the power of log e. Submitted by your y value. Always find the point. Make sure to practice. I'll be testing you guys tomorrow. Make sure to understand. must have forgotten to upload it.
Using transformations on matrices and I'll put
Right, okay. I'll make sure to upload that. No worries. Jansen.